Hello, pre-algebra. Mr. Lawrence here with your flip lesson for the weekend. I gotta tell you, I'm a little disappointed with some of the behavior with some of you when I was out Friday for the sub. So I stayed after Friday to write detentions. I will consequence. You need to behave for the sub the way you behave for me, ladies and gentlemen. It is not okay to misbehave because there's a sub. Okay? If you want to be a good kid, you gotta be a good kid even when I'm not around. Okay? Integrity is doing right even when nobody's watching. Okay, if Mr. Lawrence is here, you behave fine, and then a sub comes in and you misbehave. Ooh, I got to tell you, that's just not cool. Now, overall, most of you are fine. Seventh period, I don't think I got too many complaints from you guys. A little bit squirrely, they said, but you settled down and we're fine. Eighth period, there were a lot of people. I think 5 people that got written up Friday. Some for the behaviors 4th and 6th, and some for the behaviors 8th. Not cool, ladies and gentlemen. All right, I'm done berating you. I hope that Monday we can start a new slate. I hope you have your test graded this weekend. Get in on progress book. Anyway, today we are talking about parallel lines. And as you probably know, an elementary definition of parallel lines is 2 lines that don't intersect. A really cool thing if you go on to study higher mathematics, like I know Kareem is thinking about doing because he wants to be an astronomer, is that you'll take some geometries where parallel lines actually do intersect. Don't worry about that in here. They will never intersect in our classroom, okay? If you want to hear more about that, let me know, and I'll talk to you about that on Monday. All right, parallel lines. Some very, very special things happen when you have a set of parallel lines and you cut them by a transversal. That's a fancy way of saying another line. All right, let's see here. Let's call this line M, and we'll call that line N. And then I'm going to cut these parallel lines with a transversal. I need another line. Where's my line? My transversal, and I'm going to call it T. I just created a bunch of angles, didn't I? In fact, it looks like I might have created about 8 angles, right? I'm going to go ahead and number them. All right, I'm going to number angle. Actually, I'm going to letter them because the numbers, I don't want you to get confused. So we'll call that A, we'll call that B, C, D, E, F, G, and H. All right. Let me lock those in place. Okay, they are locked. Now, some really cool things happen. What happens is we start to get congruent angles. Some of these angles are congruent. What does congruent mean again? Congruent. Congruent means equal measure. Nick Miller would like to simplify that and say it means they're the same. Yeah, they're the same measure. Remember, we measure angles in degrees. Now, there's different ways to find out which angles are congruent. Some of them you can tell visually, but sometimes the pictures get skewed or you can't really tell. But let's just pretend that we knew that angle B was, let me see, it looks like it might be about 60 degrees. I'm just ballparking it. Okay, I know lots of angles that are congruent to it. First of all, any angles that are vertical angles. Vertical angles. Any angles that are vertical with angle B are also 60 degrees. You know how you tell if they're vertical angles? You look for an X. And if you find an X, that means that this angle here and that angle in the X are the same measure. Always. These angles on the side are also the same. So let's go up to this picture and see if we can find an X. All right, there's our angle B. Now watch this. I found an angle X. Oh, I'm sorry, I found an X out of 2 lines. Look at that. See how that's an X? Yeah, that means that this angle here and angle C are the same measure. So angle C must be 60 degrees. Isn't that cool? Any other x's, like for example, there's an X down here. Let me see, let me move this down. There's an X there. Which 2 angles must be the same? If you said F and G, you are correct. If you said E and H, you're also correct. Okay, now we don't happen to know the measures of E, F, G, or H, so we can't tell the other measures yet. All right, so when you have vertical angles, they make an X, and the opposite angles there are congruent to each other. All right, so vertical angles, we need an X. I'm going to move that out of the way for now. All right, let's see here. Now, if you have alternate, alternate, to go back and forth, to switch sides. Alternate interior, the interior of your car. Oh, the inside. Alternate interior angles are also congruent. Here's the way you find alternate interior angles. They make a Z. And when they make a Z, this angle here is congruent to that angle there. Now I need to let you know that this Z might look like an N. You know what I should do? I should make those all go together. Hold on one second. Okay, so this Z could really be an N. And those angles are the same. It could be an upside down Z, but you wouldn't be able to tell. But it could be, let me see if I can do it, a flipped Z. Boom! The angles are the same. You see that? So the Z can be going any direction, backwards, forwards, vertically. Could be like that. Okay, any direction for a Z. And the alternate interior angles will still be congruent to each other. So let's go up to this picture and see if we can find a Z. Ooh, I think I see one. I'm getting excited. All right, I got a Z right here. See my Z? All right. Well, if I know that angle C is 60 degrees, angle F must also be 60 degrees. Why? Because they're alternate interior. Now, that's not the only Z I see, though. That is not the only Z I see. It sounds like it could be a good song, doesn't it? All right, let me see here. We'll go with orange again. I think I see kind of a backwards stretched out Z. Almost looks like an S. Look at that. There's another Z. It's a backwards stretched out Z, but that means that angle E and angle D are congruent. If I knew the measure of one of those, I could figure out the other one. Okay. Now, I actually know how to do it. I'm going to show you in a moment, but there's another letter I want you to look for. And these are called corresponding angles. Corresponding angles. Corresponding angles. Okay. Corresponding angles. Corresponding angles, they make an F. And when they make an F, these two angles here are congruent to each other. And just like with the Z, the F could be going the wrong way. It could be laying on its side. It could be laying on its back. It could be laying on its back and, oops, wrong button, and going the other way. So it could be anything like that, the F. All right, when you have corresponding angles, they are the same. Well, let's see if I have any F's up here. Well, I sure do see some F's. We need a new color for our F's. Ooh, what an ugly shade of green. All right, look at that. There's an obvious F right there. Shoop, shoop. And sure enough, we already know. Oh, no, we don't already know. Excuse me. We would know then that H and D would be the same angles. Okay, that's one possible F. There are lots of F's in this picture. Another possible F would be kind of an upside down one. This would be the one we already know. And in that case, B and F would be the same measure. And we have 60 written in there, proving that we're correct. Oh no, Mr. Lawrence, what did you do? That's not part of the F. Don't do that. Okay, so there's a backwards upside down F like this. Okay, in that case, A and E must be the same. And there's one more F in this picture. And this one is like that. Okay, and that means that C and G must be the same. Oh, C is 60. G must be 60. Now, I know someone like Orlando is out there saying, you know, Mr. Lawrence, I knew that G and F were the same because of that whole X thingy we did earlier, the alternate interior angles. And you are absolutely right, Orlando. Very good. I don't know about you guys, but I think this stuff is really cool. All right, now, one more type of angle I want to talk with you about today, and then we'll let you go for the weekend, is called a straight straight angle. And a straight angle is an angle that breaks up a line or a line segment. So these two together are a straight angle. And do you know how many degrees are in a line? Well, if you don't, do you know how many degrees are in a circle? Hopefully you know it's 360. Think about Drew doing his motocross stuff. If he's on his bike and he spins around in a complete circle facing the same direction, he did a 360, which is 360 degrees in a circle. And if I take half a circle, how many degrees must be in half a circle from here to here? Well, if the whole thing is 360, then, oh, by the way, maybe I can visualize this really good here. Here's Drew on his bike. Okay. And if Drew spins all the way around, he went 360 degrees. If he only goes halfway around, halfway around would be here, he's only gone 180 degrees. Watch out, Drew. Hope you have your helmet on. You're going to hit your head. Okay, boink. All right, so there are 180 degrees in half a circle. Well, you see this straight line? That makes half a circle, doesn't it? That makes half a circle. So these two angles together must make 180. Oh, come up here. Do you see this half circle right here? If this angle here is 60, we don't know angle A, but we do know that A plus 60 must equal 180. Let's get A alone. Hey, it's a one-step equation. I'll subtract 60 from both sides. A must equal 120. A is 120 degrees. Now it gets really cool, because if you know that A is 120, A and D are vertical. Don't believe me? There's an X there. Where'd that X go? See my X? Okay, if A is 120, then D must also be 120 degrees. Okay. D and E are alternate interior, so E must be 120 degrees. E and H are are vertical. H must be 120 degrees, and I can figure out every single angle. All right, let me see. Hold on one second. Why don't you take a moment and copy this down? I've got 3 parallel lines cut by a transversal, and I only know the measure one angle. I can figure out every single angle by reviewing what we just talked about. I know that my vertical angles make an X. I know my alternate interior angles make a Z. I know my corresponding angles make an F. And I know that my straight angle makes 180 degrees. And remember, that's this case here. There's 180 degrees from this point to this point, right? Okay, check this out. I'll bet you can figure out all these out. Get this copy down, pause the video, watch. I'm going to fill them all in. Okay, E has got to be 110 because of vertical angles. See my X right there. Okay, I know F is going to be F plus 110, which equals 180. Therefore, F must equal 70. I subtracted 110 from each side. So this is 70 degrees. Sorry, I should have degree symbols on there. All right, automatically that makes G 70 degrees because of my X. Look at that, I've got 3 angles done already. All right, now let me switch colors here. I know that this one here is 110, right? Look at this, I got an F going on here. See this F? I know that in the F, those two are the same. That would be the 110 and K. So K must be 110. They're congruent angles. I got an X going on here between K and H, which makes that 110. Okay. And by the way, there's like 8 different reasons for each of these, so you can explain it lots of different ways. I'm going to get I by using G. You see my Z here, my alternate interior angles? G is 70 degrees. I must also be 70 degrees. And if I is 70 degrees, then J is 70 degrees because of the X, the alternate interior angles. All right, we're almost done. We're almost done. Now I'll pick a weird one. You probably see an easy one, but I see an upside down backwards F. See it? Which means that angle E and angle A must be the same. E is 110, A must be 110 degrees. D must be 110 degrees, right? And I'll go back to my straight angle. I know that B and D make a half circle. So therefore B must be 180 minus 110, or 70 degrees. B and C must be 70 degrees. All right, hopefully you were able to figure that out. We're going to get a lot of practice with this over the next couple of days. It's really cool, and I don't know about you. When I do it, I feel so smart. All right, Mr. Lawrence signing off. Hope you have a great weekend, guys. I love you. I'll see you on Monday.